Hello guys, welcome to SPSVERSITY. I'm here, your chemistry educator, and I'm going to take the last part of electrochemistry today. Keep watching, keep supporting. Your supports matter a lot for us, and ignore the background noise because it's a metropolitan city, so there will be definitely noise pollution. Okay, so in the previous class, what we discussed was it was about the Faraday's laws of electrolysis. So in case of electrolysis, I just want to revise a couple of things. In case of electrolysis, it is passing current and breaking the electrolyte into corresponding ions. That's what electrolysis means. And there are two laws which are very important as far as it is concerned to the electrochemistry. That's first law and the second law. And after this, the main topic which we have today is the products of electrolysis. So if you electrolyze a solution, if you're going to break down into two parts, and then the products after the electrolysis at cathode and the anode, which are liberated, that depend on a couple of factors. The first one, what are the reducing and the oxidizing species? What are the ions produced? And what is their state? Are they aqueous or are they in the molten state? And also their standard reduction potentials. This you already know. If the standard reduction potential is high, that undergoes reduction, and if the standard electrode potential is low, that undergoes oxidation when you connect them through a battery. Now, if you take molten NaCl, so what will be the products of the electrolysis? What do you mean by molten NaCl? You take the solid NaCl and you melt it. You don't have any other ions apart from Na plus and the Cl minus, both in the liquid form. So we know that Na plus is a cation, positively charged ion, and Cl minus is anion. Now, cation being positively charged, we know that it goes to cathode and anion goes to anode. And cathode, you know that the reduction occurs, and the anode, oxidation occurs. So at cathode, Na plus gains electrons and becomes Na. At anode, Cl minus, which is an anion, that loses electron and becomes Cl is diatomic, so it exists as Cl2. So I have to write half Cl2 to balance the equation. So the product at cathode after the electrolysis of molten NaCl is Na at cathode, and at anode is its chlorine. Okay, so this is how you analyze. If it is in the aqueous solution, you take the aqueous solution, and what is the product do you think as? And how do you calculate it, and on what basis do you solve that? So can you help me with this? If you're watching, you can type that, or even you can, there is a live chat over here, so you can respond over there. So what do you do? If it's aqueous, then what difference do you see? Again, in case of aqueous NaCl, you have a concentrated solution, you have a dilute solution, right? If it is a concentrated solution, the amount of water you are going to add is less, and in case of dilute solution, the amount of water you are going to add is more. In both the cases, if you take NaCl, that's in the aqueous form, you have Na plus and the Cl minus from sodium chloride, and also you have H plus and the OH minus from water. Now there are two cations which are competing, which go to cathode, and there are two anions which go to anode. So we know that at cathode the reduction happens. At anode you expect the oxidation. Okay, now at cathode, the one which undergoes reduction is, so what are the reduction reaction? Na plus plus electron gives rise to Na, and then H plus plus electron gives rise to half H2. This is one of the reaction you are expecting at cathode. If So if you consider the reduction potential value, since the reduction is happening, the reduction potential of hydrogen is more, so it's very stable. That's why whether you take a dilute solution or whether you take a concentrated solution, in both the cases, the product which is given out at cathode during the electrolysis of aqueous NaCl will be hydrogen only because of its standard reduction potential value. Now, that means hydrogen undergoes, H plus undergoes reduction compared to sodium. Now, this is both in case of concentrated and the dilute solution. What happens to two ions which are left? They are competing here, H plus, Cl minus and the OH minus. So they shouldn't be sad, right? So one case the chlorine will be the product, other case the oxygen will be the product. How do you analyze that? If the solution is concentrated, then obviously Cl minus, the concentration of Cl minus will be higher. So Cl minus gives out electron and becomes half Cl2. So chlorine is liberated. If you take OH minus, that's in case of dilute solution, if you say the concentration of OH minus will be more because you add more water, and when the concentration of OH is sufficiently high and because of overpotential, OH is less stable than Cl minus, so OH minus gives out electron and undergoes oxidation and it gives out oxygen gas. So what are the products of electrolysis of dilute NaCl and the concentrated NaCl solution? So if it is dilute or concentrated, irrespective of the concentration, hydrogen will be the gas which is liberated at cathode. And if the solution is sufficiently concentrated, chlorine will be the gas which is liberated at the anode. And if the concentration of OH minus is more, if the solution is diluted, and then O2 will be the gas which is liberated at anode. This is about an example of product of electrolysis, where if you see the previous slide, that depends on standard reduction potential values and also what are the oxidizing and the reducing species, what are the ions produced after the electrolysis. Okay. Now we move on to batteries. So what are batteries? Why do you need them? So whenever you say battery, it need not be the whole thing. Like it need not be just one battery. It can be a series of connection where you convert the chemical energy to electrical energy, right? So what is battery? What do you do? You take a cell. You have watch, right? That works on the basis of batteries. That works from batteries. So do you just supply the current to them? Now we have everything which is rechargeable. So that's a different thing. Okay, you use the torch at home at nights, right? That torch, you introduce a battery to that. You put a battery. When you put a battery, what is going to happen? The battery has some chemicals. If you have ever opened it, if you can see, that has some chemicals in it. Those chemicals have anode and the cathode. In the cell itself, in the cell construction, they have anode and the cathode and the electrolyte, which is a paste inside that. And then the chemical reaction is going to happen. That's a redox reaction and electrical energy is generated. That's why the torch glows. So in the batteries, you have two major classifications. One is the primary battery, the other is the secondary battery. Whenever I say the primary battery, so there will be a reaction. Once the reaction gets over, I mean to say all the reaction, the battery is dead. You can't use it anymore. This cannot be recharged further because there is a complete reaction. It's not the reversible reaction, it's one directional. So either the electrolyte gets electrolyzed completely, or all the electrolyte paste which is being used completely, so you can't use it further. You can't recharge also. Some type of cells is the Clamshell cell, and also the second type of cells which you have is a Mercury cell, which is found in the watch batteries. So what exactly is the Clamshell cell? What do you have as anode and the cathode? So if you open it, you just see the black paste made up of carbon and all, but what exactly it consists of? So here you have a zinc container. You can see that this is a zinc container. which acts as anode. And then you have a rod in the middle, which is black. This is cathode. So have zinc cup as anode and the cathode as a carbon rod. And so you have anode and the cathode. There should be electrolyte. There should be the paste, right? The cathode and the anode are separated by electrolyte, which is manganese dioxide and the carbon black and the ammonium chloride paste. And what happens during the reaction? So zinc undergoes oxidation to give Zn2 plus, and now at cathode the carbon doesn't participate in the reaction. So at cathode this paste, that's MnO2, reacts with NH4 plus and the reduction happens and you get NH3. So in the reaction, if you see, the oxidation state of manganese over here is +4, that reduces to +3. And now you have Zn2 plus as well. This Zn2 plus forms a complex with Zn2 plus is formed due to the oxidation of zinc container, zinc cup, which is present as anode, and this Zn2 plus reacts with NH3 over here and forms a complex. And this has a potential of 1.5 volt. This is about the Clamshell cell. So you should be knowing which is anode, which is cathode, what is the reaction happening, and also you should know whether it is a primary cell or the secondary cell. We'll go to the second type of cell. This is a mercury cell. Why is it called as mercury cell? Because it contains mercury. So this is used in hearing aids, watches, where you don't need much of potential. Okay. So what it consists? It consists of zinc mercury amalgam, okay, which is used as an anode. Here you have inside. Here the red colored one. And if you see here, the cathode is a paste of mercuric oxide. Here it is, which is a paste of mercuric oxide and the carbon. And then you don't have the rods over here, and the electrolyte is a paste of potassium hydroxide and zinc oxide. Okay, this is like a stuffing. Now overall reaction they have given, but the zinc undergoes oxidation to Zn2 plus, and the mercury, which is in the +2 state, you have the mercury here. That mercury, since it acts as cathode, that undergoes reduction. So zinc reacts, zinc mercury amalgam, the zinc undergoes oxidation and the mercury undergoes reduction. So this is the overall reduction reaction happening, which is going to give you an voltage of 1.35. And then the secondary battery. We are going to see about the secondary battery. What exactly are secondary batteries? This you can recharge further. If you have the inverter batteries at home, whenever there is current, you charge the inverter. When or UPS, you call it as UPS, right? When the current is gone, this works. Again, there is current, this gets charged. Whenever there is no power, this gets discharged, right? So secondary battery can be recharged by passing current in the opposite direction. So you can use it again and again. So what it is, how the reaction is going to happen. So we'll see that particular battery first. That's a lead storage battery, and then I'm going to go for the nickel cadmium batteries. Okay. So if you're going through the lead storage battery, this is used in automobiles and the inverters. And what it consists of? Lead anode and lead packed with lead dioxide as the cathode. Both are made up of lead only. And you have the 38% of sulfuric acid. So sulfuric acid is present here as the electrolyte. So you might have seen sometimes you have to add water or you have to add the acid to the battery. Okay. So if you have a car at home, or if you have the inverter at home, you might have seen some persons repairing by putting water or putting acid inside that. So what happens? Since you use lead as anode, lead combines with sulfate from the sulfuric acid to give lead sulfate, and 2 electrons are given out. So lead is undergoing oxidation. Now those electrons are taken in the presence of H+, that's from acid, that's sulfuric acid, and the PbO2, that's the grids which are present over here. You can see that positively charged plates. So PbO2, the lead dioxide, that's going to get converted to Pb. So here the charge is +4, here the charge is 0, 0 to +2, +4 to +2. So the oxidation and the reduction is going to happen. If you see this reaction, overall cell reaction you have to write by making the electrons are already equal. You cancel out the electrons on both sides. Lead, which acts as anode, and the lead dioxide, which acts as cathode, in the presence of sulfuric acid, both of them get converted to PbSO4 and water. That's why you have to keep adding water in the sulfuric acid whenever they get over. Okay, so when the on charging the battery, the reaction gets reversed. Okay, and the sign, the anode and the cathode are also converted to the interchangeable when the current is passed. Then we have the nickel cadmium battery, which is the other type of battery. Compared to this lead storage battery, it is long living, but it is more expensive. So what happens? You have the positive plate, that's cadmium, and nickel hydroxide, that acts as the and this is anode, the cadmium is anode, and this is a cathode. And you see the oxidation and the reduction. Here the charge from +3 to +2 takes place, and here the charge from 0 to +2. So the oxidation and the reduction reactions will happen, and it is rechargeable. Okay, and you have the electrolyte as sodium or the potassium hydroxide. You can see that positive plate is there, negative plate is there, and it is separated by a layer which has the potassium hydroxide or the sodium hydroxide. Then we have fuel cells. The major advantage of this fuel cell, why do you have to use the fuel cell, is here the byproduct is water only. In the other, if you see other cells, and what you see is after the reactions there will be chemicals, and the battery gets wasted. You have to throw it. It is not environmental friendly. But if you take the fuel cell, there are no side products like carbon dioxide or any pollution causing gases. There are not any. And then this particular setup, and also after the reaction you don't have any hazardous metals like cadmium or lead. All these are not generated, and this is very highly efficient. So as long as you keep supplying hydrogen and the oxygen, this is going to work. So what you generally do in the fuel cells, like whenever you say the fuel cell, it might be the burning of cylinders at your home or burning of petrol. In all these things, you have the fuel, and that is burnt in the presence of oxygen, and that gives electrical energy. That gives the energy. That's called as fuel cell. Now what is going to happen here? If you take the hydrogen fuel cell, that's in case of other fuel cells, in case of other cells, what you do in the vehicles and all, you burn petrol or you burn some gas like methane, and the side products will be carbon dioxide also. But here you keep supplying hydrogen, the oxygen. Okay, these are bubbled through the porous carbon electrodes into the concentrated. So here you have sodium hydroxide solution, and then you have hydrogen at one side that acts as anode, the one at cathode you have both the anode and the cathode. These are the platinum electrodes, and then, or you can even take the palladium, and the hydrogen and the oxygen are bubbled through this. And what do you see at cathode? Hydrogen, or at you can take the reactions this way. Yeah, you take the aqueous sodium hydroxide, so water will be there. Oxygen, which is bubbled through the side cathode, that undergoes reduction. Oxygen combines with water and 4 electrons to give 4 OH minus. This 4 OH minus reacts with the anode, that's passed through anode, that's hydrogen, and this gives 4 water molecules, and the electrons are given out. So this is after balancing, multiplying by enough number of electrons. You cancel out the common terms, and at the end you get hydrogen plus oxygen gives rise to water. Okay, the next topic which we have to discuss is the corrosion. and how do you prevent it? What are you going to explain over here? And corrosion is a very common phenomenon which we see in day-to-day life. Like it can be eating up of the metal by any unwanted materials or by any pollutants, not exactly pollutants, by any material which is found in the atmosphere like water or like in the presence of oxygen, where the corrosion is going to happen. This is called as oxidation of that particular metal. If you have any silver articles at home and if you wear the silver articles for a longer time, you can see the black type of coating around it, and the iron, if it kept outside for a long time, it gets rusted. And also if you have the copper coins at home, you can see a green layer, green color coating on that. All this can be the examples for corrosion. But when it comes to iron, you call it as rusting. So what happens? If you keep the iron away from water and the air, then the rusting will not be there. So what exactly is rusting of iron? And what is the phenomenon you see? Or what are the reactions behind it? That's what we are going to study today. So if you take the surface of iron, at some point where there is oxygen and the water, the oxidation starts. So Fe, iron rod has Fe, and it undergoes oxidation. What is oxidation? Loss of electrons, Fe2 plus 2 electrons at some spot on the surface of iron. Now, these 2 electrons, which are released at anode, go to the other side, and you have H plus. How is that H plus produced? You have water and you have the carbon dioxide in the atmosphere. They are going to combine to give H2CO3, which is called as carbonic acid, which gives H plus, which is a weak acid. Now, this H plus, did you understand what I mean? So iron undergoes oxidation and the electrons are generated this on the surface of iron, and these electrons go to the next spot, and in the presence of H plus, these electrons are going to combine with oxygen, atmospheric oxygen, and this gives water. And now you have to balance the number of electrons. So here there are 2 electrons. If you see Fe, here this the reaction is present. Oxidation is Fe2 plus 2 electrons, and the reduction is O2 plus H plus electron gives H2O. You have to balance. You put 2, and the first equation should be multiplied by 2 to make the number of electrons equal, and you cancel out the number of electrons. Then you get 2 Fe2 plus H2O. Okay. This is a final atmospheric oxidation. Once you get Fe2 plus, that gets oxidized in the presence of water and oxygen to give Fe2O3. Do you get that? Now, you write the overall reaction and you have Fe2 plus, that's an oxidized form of iron that gets hydrated, like that forms hydrate with the water in the presence of atmospheric oxygen and water. That's called as rust. This is how the rusting is going to happen. So when it happens, when you have uneven surfaces, there will be the chances of rusting which is more. Now, how do you protect iron from rusting, or how do you prevent corrosion? One is, always this happens at the surface. So what you can do, coat the surface with oil or with the grease or with paint, or sometimes with some chemicals. That's called as barrier protection, where the paint acts as a barrier on the surface of iron so that iron doesn't get rusted. The second one is sacrificial protection. So the reaction starts when iron behaves as anode and oxidation happens. If you prevent the iron which acts as anode, or if you make it if you make it cathode, then the reaction may not happen. So what do you have to do? You have to coat the surface of iron by more electropositive metals like zinc or aluminum. Do you get that? This is called as electroplating, or this is called as galvanizing, where you have anode. If it is kept open, the oxidation is going to happen, the rusting happens. So over the surface of that, you coat that with the more electropositive element. So the more electropositive element undergoes oxidation, then if that undergoes oxidation, that prevents iron from getting oxidized. So that particular more electronegative element sacrifices itself for iron. That's why it's called as sacrificial protection. So that zinc or aluminum says, you don't undergo oxidation, I'll undergo oxidation for you, and I'll sacrifice myself for you. That's how it all happens. Okay, if you coat if there is a, instead of coating the iron surface with the metal, sorry, with the paint, what you're going to do, you're coating it with some other electropositive metal. And the next one is called as electrochemical method. Even in the underground pipes, where it is made up of iron, it is somewhere connected to magnesium blocks of zinc blocks. That's because if you just keep the iron rod, it undergoes oxidation faster and you see the rusting. And underground pipes, after they cost too much to establish ones, and they have they cover a large surface area or large area beneath the ground. So if the rusting is going to happen, and say in 1 or 2 years, the iron pipes which have built, they are going to break down or they are going to corrode. This is definitely going to cause some major problems. So what is done at some point in the ground, it is connected to magnesium. So iron no more acts as anode, that magnesium acts as anode, so the rusting of iron can be prevented. The next one is the electrochemical method, or it is also called as cathodic protection. What is done over here? Oh, this is iron pipes. Iron pipe or tank is connected to magnesium or the aluminium. So that particular metal acts as anode. So this is called as cathodic protection, because iron is acting as cathode. The magnesium or the aluminium blocks, they are more reactive, so they act as anode. So you convert the iron is cathode and the cathode is protected. So this is cathodic protection. Now we have covered almost all the topics in the particular chapter, that's electrochemistry so far. So it's time for MCQ discussion. So I want you to answer, if you are watching, I want you to answer quickly, as quickly as possible. And I can give you the hint of for all these. This question is from Faraday's laws of electrolysis. Let me check if anybody is watching the video. Yeah. The silver cup is plated. No, I don't see where my video is. I'm having a look at it. Okay. Yeah, how do we answer this? I'm waiting for your answers, and meanwhile I'm checking if this is streaming. Yeah. A silver cup is plated with silver by passing 965 coulomb of electricity. So the amount of Ag deposited, what is it? I don't see any video which is getting streamed. We'll see if, just comment if you're looking at my videos, because I can't see it. I don't see the live session over here. Coordination. Are you able to see my videos? Just give me a second. Is getting streamed? Yes, it is. Okay, let me continue. Okay, what's the mass of silver? The question is, a silver cup is plated with silver by passing 965 coulombs. You have passed 960 coulomb of electricity. The amount of Ag deposited. So we know that 1 mole, to deposit 1 mole or to discharge 1 mole, you need 1 farad of electricity. That's 96,500 coulomb. What is the mass of 1 mole of silver? That's 107. So for 107 grams, you need 96,500 coulombs. For, if it is 965 coulombs, what is that which is needed? What is the mass which is discharged or deposited? So you cross multiply it. 965 times 107 divided by 96,500. So 96,500. So it becomes almost 107 or 1.07. So the correct answer would be, which is nearest to that, 1.08 gram. That option 1 is the right answer. The next question. This is also the similar type of question. A 5 ampere current is passed through a solution of copper sulfate for 40 minutes. So the current which is passed is 5 ampere, and the time in which it is passed is 40 times minutes. We have to convert it into seconds. Sorry, seconds, it's 60, sorry. So it's 2,400 seconds. What is the amount of copper? See, you have the copper sulfate solution and the copper is being deposited. So that's Cu2 plus 2 Cu. How many moles of electrons are needed? 2 moles of electrons. Okay. Now, for 1 mole of copper, you need 96,500 joules. Sorry. Yeah. Coulombs. Now, if it is for 1 mole, then they have given, so you have to multiply 2,400 with 5. That will give you 12,000. So 1 mole is nothing but 63.5. If you see, for that 2 times 96,500, because what do you see here? 2 moles of electrons are there. So for 12,000, if the 12,000 coulombs are there, what is this? That's what you have to see. Okay. Let me calculate. I'm using the mobile for calculations. 63.5 times 12,000 divided by 2 divided by 96,500. This comes out as 3.94 gram. So how do you solve this question? The atomic mass, that's nothing but 1 mole. That's a mass of 1 mole. That needs 96,500 coulombs. That's 1 farad of electricity. So if they have given particular mass, then you have to find out this way. Or if they have given particular amount of coulombs, then you have to find this way. Just you cross multiply and get the answer. That's it. Yeah. Aluminium is reduced by electrolysis at low potentials and high currents if 4.0 times 10 to the power 4 amperes of current is passed through the molten aluminum oxide for 6 hours. What is the mass of aluminum which is produced? You have to assume the current efficiency as 100%, and the atomic mass of Al is given 27 gram per mole. The same way, see, aluminium is reduced from aluminium oxide. In aluminium oxide, the charge is aluminium of aluminium is 3 plus. This takes up 2 electrons, is reduced by electrolysis. You are reducing it to Al. So, for 1 mole of aluminium, you need 3 farads. That's 27 gram needs 3 times 96,500 coulombs of electricity. So they have given the amount of electricity passed is equal to I times T. So I is, they have given the current 4.0 times 10 to the power 4 times 6 hours, 6 into 3600, because 1 hour is equal to 3600 seconds. Now that comes out as, so you also calculate 4 into 6 into 3600, that's 86,400 into 10 to the power 4. So 86,400 into 10 to the power 4 gives how much mass? So it's 86,400 into 10,000 into 27 divided by 3 divided by 96,500. It's 8.0. Okay, let me give the answers. You know how to cross multiply, right? These two. That's 27. Mass is equal to 27 times 86,400 times 10 to the power 4 divided by 3 into 96,500. So the mass which you are going to get is 80,580. That's nothing but 8.05 into 10 to the power 4. That's nearly equal to 8.1. So the correct answer would be option 2. Yeah, we have the next question. The most convenient method to protect the bottom of the ship made up of iron is, this is a simple question which you have already discussed. So you have to see, you have to remember the electrochemical series in which you will get to know which is a more reactive and which is less reactive. So lead is not so reactive as iron. So iron undergoes rusting because iron undergoes oxidation. Now you have to stop iron from getting oxidized. So you have to coat with a reactive element, that which is reactive than iron. So that iron is made as cathode and the cathodic protection is done. So you can prevent iron from getting oxidized. If you see lead, tin and lead, all these are less reactive than iron. So if you coat or if you connect iron with any of the elements, you can't stop rusting. So magnesium, on the other hand, is more reactive. If it is more reactive, it undergoes oxidation preference to iron. That's why cathodic protection can be done. When 0.1 mole of manganate is oxidized, the quantity of electricity required to completely oxidize manganate to permanganate is, see, you have to find out the oxidation state. MnO4 2 minus to MnO4 minus. I think how you know how to calculate oxidation. Oxygen is -2. This you take as x. 4 into -2 is -8. Plus 2 is the oxidation state is +6 here. The oxidation state is +7 over here. So to convert, the change is 1. So for 1 mole of electrons, you need 96,500 coulombs. Now here you have 0.1 mole because the change in oxidation state is just 1. So 1 farad of electricity is needed for 1 mole of manganate to getting converted to permanganate. So for 0.1 mole, how much you need? Just do the multiplication. 96,500 times 0.1. That's going to give you 9650 coulombs. So option 3 would be the right answer. So the next question is here. We have the next question over here. The Zn acts as sacrificial or cathodic protection to prevent the rusting of iron because. So Zn is used for the cathodic protection. So the cathode is if you see, iron is made as cathode and it is protected. If iron has to act as cathode, it should undergo reduction rather than oxidation. Generally the cathode is less reactive compared to anode over here in the electrochemical series. That means its reduction potential is more or oxidation potential is less. Then what is oxidation potential? It is capacity to undergo oxidation. Reduction potential is its capacity to undergo reduction. It's a potential to undergo reduction. So you are coating it with zinc. Zinc is more reactive. If it is more reactive, it undergoes oxidation easily. If it undergoes oxidation easily, then its oxidation potential is high. OP stands for oxidation potential. So E0 of oxidation potential of zinc is greater than E0 oxidation potential of iron would be the right answer. On electrolyzing a solution of dilute sulfuric acid, so condition is dilute sulfuric acid between platinum electrodes and the gas evolved at the electrodes are. You have anode in the cathode and you have the dilutes H2SO4. We know that the cation is H plus in both the cases, in water and this thing. Both are H plus. And at anode you can expect SO4 minus and the OH minus. And the solution is dilute. If it was concentrated, maybe you get SO4, SO2 as a gas. Since it's OH minus, at anode O2, it's a dilute solution they have mentioned. O2 is a gas liberated, and at cathode there is no competition because both are same. So O2 and H2 will be the gases which are given out. In electrolysis of sodium chloride with platinum electrode, hydrogen is liberated at cathode. With mercury cathode, it forms sodium amalgam because. You have to find the answer for this. What is it? In electrolysis, electrolysis of NaCl they have given. Okay. So NaCl, that will ionize into Na plus and the Cl minus. And with platinum electrode, if it is the solution is taken, then it will ionize into H plus and the OH minus. If platinum is used as the electrode, because platinum doesn't react, it is an inert electrode. Yeah. If platinum is taken, this is an inert electrode. This just acts as a source of the sink of electron. So platinum is used as an inert electrode. Then you would experience, or you would see, hydrogen gas will be liberated at cathode. This is a cation and its reduction potential value is greater than sodium. Okay. Now, if mercury is used as cathode, then H plus is not liberated, or the hydrogen gas is not liberated, because the reason being it has high hydrogen over voltage. Because of this, with preference to H plus instead of H plus, Na plus gets discharged and it gets converted to sodium, and that combines with mercury to give sodium mercury amalgam or sodium amalgam. Because Hg is not more inert than Pt, more voltage is required. Sodium is dissolved, it is not. Concentration of H plus is no, more voltage is required, that is called as over voltage, to reduce H plus at Hg than at Pt. So option 2 will be the right one. If mercury is used, this we have already discussed. If mercury is used as a cathode in the electrolysis of aqueous NaCl solution, if it was any inert electrode, hydrogen will be the product at cathode, otherwise Na plus will be discharged because of high hydrogen over voltage. Yeah. So we have completed the electrochemistry successfully, and if you have any doubts or if you suggest any improvisations, please comment on the chat section. Thank you for watching. Keep supporting SPSVERSITY. Good night.